Here's day 1 of chapter 1.6, inequalities. Linear inequalities are solved just like equations unless you have to multiply or divide by a negative number to isolate the variable. So with this example, 3x is less than 9x plus 4. We want to solve this just like we would a regular equation. So we've got to move this 9x and subtract that from both sides, and that would cancel out. And we would have negative 6x is less than 4. And now that we have to divide, and it happens to be a negative number, we're going to divide by negative 6. We want to flip this inequality. So now it's greater than and then just simplify our equation here, or inequality. So we have x is now greater than 4 divided by negative 6 is negative 2/3. And so our answer is x is greater than negative 2/3, and that's solving that inequality. Okay? And sometimes we will have to solve a pair of inequalities simultaneously, which means we're going to work these two inequalities at the same time. So what might help is if you draw a line down from each inequality to show that you've got 3 sections of this inequality that is to be worked on. So we're going to add 2, and we have to add 2 on the left side and add 2 on the right side. So in the middle, that cancels out. You're left with 3x. Over on the left, your 4 plus 2 is 6. And on the right, 13 plus 2 is 15. Currently, your inequalities are still the same. And now we have 3x. We need to get x by itself, so we have to divide by 3. And this is dividing by a positive number, so we do not have to flip any symbols. If we had a negative number, we have to flip both of those. This is 2 is less than or equal to x, which is less than 15 divided by 3 is 5. And so this is our answer to the inequality. X is greater than or equal to 2. X is less than 5. Okay? So that's basically what we're doing to start with. Some things to remember are having to graph inequalities. So with looking at the symbols here, we have the symbol, this is less than, and if we were to graph from a point, we would have an open dot, and our graph would go less than, so to the left. And you want to make sure that it's visible and understanding what is happening. Whether you do that on the line or above the line, it's up to you. This next symbol is greater than. So again, greater than, not equal to, is an open dot, and we are going from the dot to the right and drawing an arrow. Okay? This symbol here is less than or equal to. So we can be less than or we can be equal to. It's one or the other, doesn't have to be both. But to show that on a number line, you fill in the dot and then you graph to the left for less than. And finally, the last symbol here is greater than or equal to. And again, you're going to fill in dot and you're going to shade to the right for greater than. Okay, so one thing to remember is that you are always reading these symbols from left to right. So the left side is less than the right side. The left side is greater than the right side. Okay, so you're usually, as far as understanding what these symbols are saying, you're reading them left to right. If I had something like x and on the right hand side with a number on the left hand side, you might want to read this because the x is on the right hand side. You're going to read from right to left, and you're going to say x is greater than the negative 4 because the symbol, the mouth of the symbol, is open towards the variable, that is the greater value. So it is usually the mouth of the symbol is opening towards the greater value because it's like an alligator wanting to eat more food. So the alligator wants to eat more food. So greater than, the mouth is open towards the greater value. All right. The other thing we have to remember is interval notation. With the less than or greater than symbols without the line underneath, just like on a graph, it uses open dots. For interval notation, it uses parentheses. Okay, remember that? And when you have the line underneath the inequality representing equal to be also equal to, you are going to be using these brackets, these straight brackets. So looking at some examples of graphs, we have x is greater than 3. And on a number line, I'm going to have that set up, and I have my 0 and my 3 on the number line. So what I'm going to do is, since that's greater than without being equal to, I'm going to put an open dot on 3, and greater than is going to be shaded to the right. Okay? And make sure it's visible and understand what's going on. Okay? As interval notation, okay, I only have one number that is represented here, and x is greater than 3. So where am I supposed to stop? It's just going to keep on going forever and ever because there is no stopping point. And that means we're going on to infinity. So I always write my smaller number on the left side, comma, and then my larger value. Whether it's a number or infinity, it's going to be written smaller left, greater on the right. Now, this is a open dot. There's no line under the inequality, and that is referencing the 3. So I'm going to have parentheses at the 3. And then for infinity, you're always going to have parentheses because you can never equal infinity. Infinity just goes on forever and ever. Um, with x is greater than or equal to 3, I'm looking at the graph. I still have 0, my 0 just for a base point. I have my 3 graphed on there. I'm greater than or equal to, so that means I'm using a solid dot instead of an open dot, and greater than, again, is still going to go to the right. Okay? Now, for interval notation, again, I'm going from 3 all the way to infinity. But this time I have a solid dot. I have that line under the bracket or underneath the inequality. So I'm using a bracket, straight bracket for the 3. And even though I'm using a straight bracket for the 3, I have to use a parenthesis for infinity because I can never actually equal infinity. For x is less than 3/4, again less than, no line underneath, I'm going to have an open dot at 3/4, and I'm shading to the left. And now, because my values are going to be going to the left and being less than my 3/4, that means I'm going all the way to negative infinity because there's no stopping point going to the left. So I have to go with negative infinity on my left-hand side, and 3/4 is on the right-hand side because 3/4 is my upper limit, my upper value, my greatest value here. And because it is less than and not equal to, I'm going to have parentheses on the 3/4 and again parentheses on the negative infinity. Okay? And finally, my last example here, I've actually got x being compared to two numbers. That means I'm going to have a lower number and an upper number. So my x is greater than or equal to 2 and less than or equal to 5. So 2 is my smaller number, 5 is my larger number. For the 2, x, when x is referenced with the 2, I have a greater than symbol going towards the x anyway, with a line underneath. So that means I'm going to have a bracket, and I have no line under the symbol when it's referring to the 5, so that means I have a parenthesis on the 5. On the graph, I'm going to have a solid dot on the 2 and an open dot on the 5. And because x is in between the two, I am shading in between the two dots. And that's it for day 1 of 1.6.